Now we're going to use some of our prior knowledge about special right triangles to find apothems or apothems for other polygons. This can be used for equilateral triangles, hexagons, and should be dodecagons as well. And let's see, and actually squares too. All right, so you can also use special right triangles to calculate the apothem. So I said equilateral triangles, squares, regular hexagons, and it also works for dodecagons. If you were given the perimeter, so one other thing we're practicing is I'm not going to give you the side, I'm giving you the perimeter, and you just have to do an extra step to find the side. So first of all, we start like we did before. We're going to find the central angle. So the central angle is 360 divided by the number of sides, which is 3, and we get 120 degrees. Then I need to calculate each side length. It says teach, but it should be each. And I'm going to take that 36, how many sides are there? Divide by 3, and it's 12 inches. These two numbers are not really related. It's a coincidence because I picked a perimeter 36 inches. If I had picked, say, 30 inches, this answer would be 10 inches. So there's no relationship there, really. All right, now I'm going to label the triangle with the apothem, the base, and the known angles. So there it is, the apothem or apothem. I know that this angle, well, it's not going to be the 120 degrees. It's going to be 120 divided by 2, or 6 degrees. And finally, the side there is not the whole 12 inches. It's half of the 12 inches, so it's 6 inches. Then I'm going to use, I recognize this triangle. This is a 30, 60, 90. So I set up another right triangle next to it so I can set up a proportion. Now, could you use trig to do this problem instead? Absolutely. But if I'm looking for an exact answer, you really do want to use the special right. So here I'm saying 1 is to square root of 3 is a is to 6. See that proportion there? 1 over square root of 3 and a over 6. Then I can multiply both sides by 6, and I get a is 6 over square root of 3. And you would be fine with that answer. I'm going to go ahead and rationalize the denominator. It's kind of good for you to see it. So you get 6 over square root of 3. The way you do that is you multiply the numerator and the denominator by the same thing, the square root that's in the denominator. And so I get 6 square root of 3 over square root of 9, which is 3. Oh, that's the same thing as 2 square root of 3. So both of these values are the correct answer. 2 square root of 3 and 6 over square root of 3. Technically, any of these are the same. Some people, again, many of you prefer not having fractions, and there you go. You have it without a fraction. So on your problem, you will be working for individual practice. You'll be doing a hexagon. Again, you can use trig or similar right triangles to do that one. So for further reflection, what prior knowledge can we use for finding the apothem, especially if special rights are involved?